Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello students, I hope you're doing well. I'm back. I'm teacher Callixte. I teach mathematics. Today, we are going to learn together with the senior 3 students on the continuation of the last lesson we had. Remember, we were on unit number 5 on my PowerPoint presentation. As you can see, we are on unit number 5 still, but this is the lesson number 3. We are going to continue to see how to solve the quadratic equation graphically or by using graphical methods. But still, we need to verify and find out if for sure the answer we got is the same if we use any other method. Now, as you remember, I need to go straightly on the last example we had. We had example number 1. Example number 1, it was 2x, it was y equals 2x squared plus 3x minus 4. This was the example we had before. If you remember very well, it was this example. Let me use the... We had this example. As you can see here, y equals x squared plus 3x minus 4. That is the example we had, and we've gone through different steps. We've gone different steps, and step number 1, it was to build the table of sign, and step number 2, it was to plot this equation on a graph. I think you remember we did that. Let me now give you the overview of it. The step number 1, it was to find the table of sign, or build the table of sign. Build the table of sign. This one was step number 1. And the step number 2, it was to plot. To plot the equation. To plot the equation on a graph or on a Cartesian plane. And you remember, we've done this within the last lesson. And from the question that we had, we were asked to find the value of x when y is given, and also the last point, it was to find how, what I can call like number 2, it is to determine how to solve a quadratic equation by graphical method. This one was regarding the sub-question number C on that example we had before. And then from here, I want to give you some points you need to follow if you are solving your quadratic equation using graphical method. As you remember, when you check on the graph that we had, our graph was like this. This one was x, and this one was y. And as you remember, we had point number 4, and also the point 1 over here. This one was our graph. If you check it on the PowerPoint, I want to show you that graph. Now look at this. When you look at this graph, as you can see, we have where x was at -4 over here. You see this. And also we have the other point where this parabola was cutting x-axis at point 1. So I want you to know this. Whenever you are solving a quadratic equation, and after plotting your equation on a graph, you need to see where the parabola is cutting x-axis. And where the parabola is cutting the x-axis, whether it's within 2 points or maybe 1 point, that is the solution of your quadratic equation. It means if our graph, the other lower point was at point number 6, it was over here, number 6 here. And the other one was at 1, if I remember, at point 1, somehow like this. If our graph was like that, this is where we find the value of x. This is x number 1, and this is x. You may call number 1 or number 1 this one. This is where it is equal to -4, and this is where is equal to 1. So these are the solution of your equation. And for today, we are going also to do the other example, and we finish it and see how for sure you solve it. But before we do this, I want you to verify and find out if for sure the answer of 1 and the -4 of course, this equation we had before, which was x squared plus 3x minus 4, we need to find out if for sure these are the answers. And as you remember, we did the first method. The first method, if you need to verify. But before you verify, you need to find that, or to remember that if this one is -4 and the one down is 1, we call these ones the roots. We call them the roots of our quadratic equation. We call them the roots. And it's not only this name. You can also call them the x-intercepts. If the parabola cuts the x-axis, if the parabola cuts the x-axis at 2 points, this means that you have two roots. You have 2 roots. As you can see from this graph, you had somewhere x was -4 and the other one where x was at 0.1. These are the roots. Now, we are going to verify by using any other method and see if we get the same answer as when you use the graph method. Let's use the factorization method because it's the one we have already started. Factorization method. When you use this method, we are going to use it and we solve this. And we solve x squared plus 3x plus 4. When we solve it, we will find if we get the same answers as the ones we found here. Now, when you factorize this is squared. Don't get confused. When you factorize this, you need to remember what you do. This is actually called the sum, and this is the product. And if the sum is 3, and this is negative, and the product a times c goes to -4, you need to look at these 2 numbers. Which numbers can I add and I get 3, but when I multiply, I get -4? Let me have 4 and -1. If I take 4 plus -1, I will get 3. If I take 4 times -1, I will get -4. And if I do work on this, what do I get? I get x squared plus 4x minus x, and then -4. Do you see? And from here you get x squared plus 4x, I put them together, minus x plus 4. I also put them together. What do I get? From here, I put x out of the bracket. I remain with x plus 4. And also here I get x. I get 1 goes out, and I remain with the x plus 4. And as you can see, here we have 1. What do we get? I need to take this one and this one. It will be x minus 1. And also this one is common for both terms. And though we remain with x plus 4. As you can see, we need to look at the roots. When you equalize this one by 0, you remain with x minus 1 equals 0, and also x plus 4 equals 0. Here we have x equals 1, and here we have x equals negative 4. Do you observe this, students? It means from our first example we had on this graph where x is equal to 1 and where x is equal to negative 4 when you use a graph method or graphical method. And you are getting the same answer if you use the what? If you use the factorization method. It means we've been so correct with the first answer we had. Let's now have like a very few minutes or a few seconds. You copy this, and after copying this, we are going to go with the next example so that you can understand better how to solve a quadratic equation by using graphical method. Have some few seconds, and you copy. I hope you finished this part. Now, thank you very much. As you can see from the PowerPoint, we have example number 2. Our example number 2 is to plot the graph of y equals x squared minus 3x plus 2 for values of x between negative 1 and plus 4. You need to include 1.5 in your table of values. So number B, we will use the above graph to solve x squared minus 3x plus 1 equals 0. Students, we are going to do this question together, and then we finish it. Okay? And I want you to have an exercise notebook, and also a pen and a pencil, and then we work on it. Let's go to example number 2. Example number 2. Our example number 2, it is x squared minus 3x. Solve x squared minus 3x, then plus 2. As you can see, you need to follow the same steps as we did the first example. What you have to do first is to look at the table of. I want to now you go step by step. Step number 1, it is to find the table, to build the table of values, because from what they told us, we need to plot the graph, and after plotting, we solve it. Table of values, they told us that x is varying between negative 1 and what? Negative 1 and positive 4. And we don't have to put these last numbers because we don't have greater than, less than or equal. We don't have that sign. Now here we have x. We need to start from negative 1, 0, 1, and they told us to put 1.5, and also 2, 3, and lastly 4. From here, I told you you need to follow the same steps. If I have this content 2 here, I will copy it. It doesn't change because it's a constant. It doesn't have any other variable around it. There was x power 0, and this gives 1. Okay? This gives 1. That's 1 times 2 gives 2. And from here, you need to go to negative 3x. we are going to look for negative 3x. What do you get? I take negative 1 times here, I will get 3. This one I will get negative 0, because 0 times negative 3 gives 0. Here I get negative 3x. Here, what do I get? It is 3 times 1.5. That is 4.5. You multiply by using your calculator. There is no problem. You get 1.5 times 3. Remember, it is a negative sign which is there. We get here negative 4.5. And then here, you get negative 6. Here you get negative 9. Here you get negative 12. These are the values. We go then to the other one. What is that? It is x squared. X squared. For x squared, we have now negative 1 squared. That is 1. Here we have 0. Here it is 1. 1.5 squared times 1.5, you get 2.25. This. Here you get 4 because it is squared. Here you get 9. Here you get 16. Do you see this? Now you go for the value of y. When you go to y, I told you you have to sum up this. You have to sum up all these. When you sum up here, you get 5. This is 6. This is 2 because you are summing up. This is negative 1 and 1 gives us 0. Here we have 2 minus 4.5 plus 2.25, and you get negative 0.25. Okay? And here you have, this is, where was I? This is negative 4, and this is 0. Here you have negative 7, and here you have 2, because negative 7 and 9 gives 2. Here you have negative 10, and here you have 6. Okay, students? So we've rushed to find the table of sign. When you finish to find the table of sign, let me clean this part. When you finish to get the table of sign, what do? Step number 2, it was to plot. Step number 2, we plot. Plot the equation. The equation, okay? What do you get? You remember I told you it's better to have the graph paper because it gives you the real information. Here we'll be assuming so that we can get the answer. Because our blackboard is not graduated, we have x here and we have y here. Now we are going to put some values. But it's okay, you can use this. But for time management, let's say this is 1 and 2. I will just assume the same. This is 4, 5, then 6, 7 over here. We have kind of negative 1 here. Negative 1, negative 2, negative 3, negative 4, negative 5, and you have negative 1, negative 2, negative 3, negative 4, negative 5. Here we have 1, 2, 3, 4, 5, 6. Almost looks like I'm having the same size. Now, when you look at this, we have the points. We have points negative 1 and 6. That's what I told you the other time. You have negative 1 and 6. What is that point? Negative 1 on x and 6 on y. You try to locate your point. Your point is over here. This is point number 1. The other point is 0 and 2. 0 on x and 2 on y. It's here. This is negative 1 and 6. This is 0 and 2. The other point is 1 and 0. 1 on x and 0. 1 on x and 0 on y. This is the point. 1 on x and 0 on y. It's better to use a different color. You have this one. Okay. The other point is here. 1.5 on x and a negative 0 point. 1.5 is in the middle of this, and the negative 0 point, it goes over here down. Like here, negative 0 point. This is the other point we have. Okay? And the other point is 2 and a 0. 2 on x and a 0. It's here. The other point is 3 and 2. 3 on x and 2 on y. It's here. Like this. This is a 3 and 2. The other point is 4 and 6. We have 4 on x, 4 on x, and a 6 on y. This is the point. This is 4 and 6. And as you can see, we are going to join our points. I told you you used to use your hand. You can't use a ruler because the points are not on a straight line. You use your hand and you try to join these points. You remember? We start from here. This is the origin, not the point that we have to put in our set. We come this way, like this, like this, like this, this. Have you seen? And this is a parabola, actually. This is a parabola that was given by the equation. It was given by the equation x squared minus a 3x plus 2. Have you seen it? Now, if we were told to solve, we are done with the first part, that is sub-question A. Sub-question B, it is to use the above graph to solve. Look at the PowerPoint. It's to use the graph to solve. When you use the graph to solve, I have given you the information, which is very important. I have told you if the parabola cuts the x-axis at 2 points, this means that you have 2 roots. From our graph, we are going to see where the parabola is cutting the x-axis. And where it cuts, those are the values of x. It means you look where it is cutting. Where? Number B. It is to solve graphically. To solve graphically, you just have, or by using the graph method, by graphical, it's better to use this, graphical method, you just look where the graph is cutting the x-axis. Can you tell me where? I think everybody sees it. It's here and there. Look at this. It comes from here, goes down, and it cuts x-axis at point 1 and at point 2. So where x, 1 is at 1, and the other x, it is at point 2. These are the values of x you get, and we call them the roots. We have 2 roots. We have 1 root. It is where x gives 1, and the other one, x gives 2. And you are done. These are the solutions you were looking for. And as you remember, from the equation, if it is given with power 2, it means at the end of the day you need to have 2 values of x. And it's what we have here. So it is very simple. When you're solving a quadratic equation using graphical methods, you need to follow all these steps. Step number 1, what you do is to build your table of sign. And you've seen how to build the table of sign. When you finish to build the table of sign, what you do, secondly, is to plot the equation on a graph. And the third thing you do, you just read from your graph where the parabola is cutting the x-axis. And those are the values of x you were looking for as you were solving. So students, I think this is very understandable. And I am going to give you a homework and you keep on working on this. Actually, you don't have to make it as a big deal. It's just very easy as long as you follow the steps that I'm giving you to build a table of sign, to plot your equation on a graph, and also to read where the parabola is cutting, your x-axis. Now, I thank you very much. Let me leave you with a homework. You keep on working on them. And from the homework, I can also remind you where you need to apply all this in everyday life. You find more examples of where you can apply this. When you are seeing the parabolic antennas, those are the applications of the things we are learning. When you look at the cannonball trajectory in physics, you need to go under calculations of all this. You see how it goes by not on a straight line, just by forming a kind of curve, you see? Now, and the last thing that you have to do is to work on the homework. I have given you it with the last time, but I want to now you keep on working on them because I gave you so many different questions. I gave you 5 questions. You keep on working on them. I will see you then. Thank you very much for your kind attention. We keep in touch. Bye.